will happen when you have a 3-item scale? The problem is that you will not be able to estimate it standalone. Okay, so just to help you understand this, okay, let us do this problem together. So this 2-item model, we saw it will not run, right? It is an under-identified. So now let us solve this model. Let us solve this. So we have okay. Everybody compute the degree of freedom of this model now. Let us compute the degree of freedom of this model. So what will it be now? K plus 1 by 2 minus hash theta. What is K now? K is 4. So K plus 1 by 2 is equal to 10, right? What is hash theta here? Number of factor loadings is 2. Number of measurement errors, 4. Number of structural paths, 0. Number of structural errors, 0. Number of covariances, 1. So this is a covariance, so it will be 1. And then number of independent latent factors. Now this is an independent factor and this is also an independent factor. So there are 2 independent factors. So it is going to be 2. What is the number of parameters to be estimated? It is going to be 9. 2 plus 4 plus 3. Right? So what is your degree of freedom now? It has become 1. This is an over-identified model. So what is the message? The message is you cannot run this. You cannot estimate it standalone. This is not possible. This is not possible. But this together, this is possible.
Okay, sir. Got it, sir.
I have a question. The first question is related to my yesterday's question, which is about model identification in case of formative construct. So how do we go in case of formative construct?
So what is a formative construct? The formative construct is nothing but this kind of a model, right? What is a formative construct? This is your model. Let me just scroll this up. So, sorry. Yeah. Yes. So you have F1, F2, and you have these causing F3. Okay. So this becomes your F1 and F2 are formative indicators. They may have their own measurement models. Okay, but they are forming F3. So you have the same rule that will apply. df is equal to k plus 1 by 2 minus hash theta. You can compute, these are your structural paths. Structural path 1, structural path 2. You will have a structural error here. Okay, and then you will have all those. You can compute this degree of freedom the same way.
We have to assign 1 year also in one.
Yes, absolutely, absolutely. Yes. So one, at least one path going out of the latent factor has to be constrained to 1.
Okay. Sir, another question is related to the model specification. We assume that the error should be related to one factor, and sometimes we see that the error of the one factor is co-varying with the error of the other
Ah,
factor, or
yes,
even with the item. So, what is
yes.
the
So
indication?
that is okay. That is okay. But so that means what, the two error terms co-vary. That is fine. But this error is this path. This error is complete. This measurement error belongs to item 1, item 3. There is another error that is correlating to this error. That is okay. But this error belongs to this item only, right?
Okay, sir.
Yeah.
Thank you, sir.
Yes. Yes, Ramini,
Sir, how do we know how many constraints we need to put and where?
which constraints?
So you said, right, we need to put the constraints, just like you said, you have put the constraint 1, you have chosen the, what should I say, the scale maybe, that if the item 1 of factor is measured from 1 to 5 scale, then the same for
So,
item 2, yeah, so that's what.
so that is what I said. You can put the one constraint on this path, or you can constrain this path. It is absolutely your choice. There is nothing, nobody is going to tell you you should put it on the path from F to I1 or from path from F to I2. It is purely your choice. So there is no such thing as whether it is right or wrong.
And it depends on which scale we are measuring those items.
It doesn't matter. Usually it doesn't matter. You can constrain any one of the items to 1. It will work.
Okay, sir.
And if you are talking about this -1, then it is very easy to say that the software will tell you you need to put one additional constraint. Why one additional constraint? Because the moment you will put one additional constraint, my parameters, that my work, that the parameters that I have to compute will decrease by 1. Okay, because then you will have put a constraint. So I will be able to get a degree of freedom of 0. Right?
Okay,
So
sir.
that is how. If you had a degree of freedom of -2 in your model, then the software will give you give you an error saying that you need to put 2 additional constraints. So
Okay, sir.
that my degree of freedom can become 0.
Okay, sir. Sir, in this SEM models, they can be based on already established models, or we can also put our new models.
Established models mean?
Which have been tested earlier, or it
Then
means the
what is
model is
the
already there in the literature and we are just fitting our data into the existing model.
then
Checking.
what is your contribution to research? What
Okay,
is
okay.
your
So it means
contribution?
in this we are putting some new model and checking some new relationships.
See, you can have, these are your measurement models, right? These are your constructs. This is perfectly fine because this measurement model is given in the literature already. But your contribution will come how these different factors or these different constructs are going to be related. That is where your contribution is going to be, right? How this F1, F2, F3 are going to be connected. If you know even F1, F2, F3, how they are connected, then what is the novelty you are bringing in your research? You are just testing the model already known, right?
Okay, sir.
Yeah.
Got it, sir. Thank you.
Yes, Ashwin?
Sir, I have 3 questions, sir. For control variable, usually we use only one item. Would that not be?
So control variables, the issue is, so for example, we will do an example with control variables. So for example, you have gender or age, you can actually directly use it as an observed item in the model, right? So you can have latent factors. You can also have observed items like this. Uh, so because they are just one item and the idea is that they are more tangible in the sense you don't, the measurement error may not be so much. Okay, so that can be done. And the second thing is because of they are control variables, you don't, uh, uh, at times you don't need to worry so much about their whether they have been uh, how many items are there. So if you had something like uh, you had a perceptual variable, so for example social desirability you want to control for, okay, which has its own set of items, then you will model the latent factor for social desirability also and then control it. But if you have these kinds of demographic variables, you can model them uh, as a observed variable in the in the analysis along with the latent factors. The third thing is, if you have even one factor, it is possible to model uh, factors, latent factors with just one items also, with one item also, that is possible to do.
Yes, and the next question was, you mentioned that, sir, at least one path going out of the latent factor should be constrained to one. So
Yes,
suppose a factor has got 5 items. Can I constrain any of the paths from
any
right
of
one to?
this,
And
any
why
of
is why
this.
is that one any one has to be constrained? Any reason as to why
And
it
so
has to be
that is
constrained?
what I said, that you see, this observed item, you know, it is ranging on a scale of 1 to 5. But the software has to estimate this latent factor, right? This is the true factor, the true factor of F1, and that is what you want to use in your regression. So when the software has to estimate this true factor, it can estimate it, but what should be its range? It should it estimate between 1 to 5? Should it estimate it between 1 to 100? Should it estimate between 1 to 1000? You need to tell the software that you should estimate it between 1 to 5 or 1 to 10 or 1 to 100. So this, applying this unity constraint here, it is an indication to the software that this factor needs to be scaled between this range of 1 to 5.
Sir, and the previous DF equal to 1 over identified, which you had done, sir,
Yes.
that double-headed arrow, um, uh, the ILFE is 2 because it is on both sides, because F1 and F2 both we are computing simultaneously.
Yeah. And because, so in this case, the size of this. So, yes. So in this case, they are independent because F1 is not causing F2. They are both existing as factors and we are just estimating their correlation or covariance. F1, how much is the covariance between F1 and F2, right? So
There is a path also.
if
Why not that beta coefficient is computed? There is a path.
because you have not specified it now. Where have
Okay.
you have not specified? You have said there is a correlation. If you had said this arrow, then there would have been only one independent factor, F1.
Okay. Mhm. Okay, sir.
But here you have modeled a double direction arrow. And even then, even if you would have specified this single direction arrow, even then your degree of freedom would not change. It would still come out to be 1.
Yes, sir.
Yeah.
Okay, sir. Thank you, sir.
So that is what will happen. Yes. Shubhanshu.
Sir, I have two doubts actually. My first doubt is under identified and unidentified model are the same thing, right?
There is nothing called as unidentified. We say under, over, or just identified.
Okay, okay. Because sir, if, when we run the AMOS in the analyze property, we get one option that try to fit unidentified model. That's why I was a bit confused.
Okay,
Uh,
we'll look at it when we run the software. You point it out, and then I will explain. But
yes, sir.
usually, when we talk about identification, the terms that we use is over, under, and just identified. Maybe it is assuming, maybe it is using unidentified as the,
Yes, sir, because it
yeah.
comes under analyze properties
Yes.
and numerical this thing tab.
So yeah, yes.
Yeah, and so my second doubt is when my model comes to be under identified, then you were stating that we need to add a construct or either increase the items in a
Yeah,
construct, right?
absolutely. Yes.
But suppose one of my latent construct has only 2 items, and if I add another item which is having very low loading, then later on it goes to it affects the
It of,
validity of my model. Uh,
yes.
then how to deal with it?
Then the only way to deal with it is you will have to do the estimation like this, like this. You
Okay,
will not be able to estimate it separately, but you will have to estimate it jointly with some other construct.
okay, sir. Got it. Thank you so much.
Yeah, yeah. Akash?
Sir, suppose we have taken a construct with more than 3 items for
Huh,
over identification,
huh,
and later on, while checking the reliability, we have to drop a item or two.
yes.
So, will it have an effect on the
Yeah,
identification?
so your identification will change. The moment you will drop the item, it will become just identified with
So
3 items.
that means having more than 3 items does not ensure over identification.
Yes, but yeah, so usually you are still giving yourself a little more chance. But even then, if it is 3 or 2 items, what I am trying to tell you here is, then you will have to test its measurement model along with some other factor. You cannot test it separately, standalone.